This video covers the first part of the review for Chapter 9. What will these different blocks of code output? First problem, block number 1. What is this output? This is pretty easy to figure out. I take a look at this loop right here for I in range 5. I know in this type of loop, I is going to go from 0 up to, but not including, this number. This number will take us to the 4. We start from 0, we go up to 4. That's what I is going to equal. But before I print it out, I add 1 to it. And then instead of printing out 0 through 4, it's going to print out 1, 2, 3, 4, and 5 when I run it. I go ahead and run it, and I can see down here in the Python shell, indeed I get 1 through 5. Block number 2. What is this going to output? With these two lines, a pretty standard for loop. I is going to go from 0 up to, but not including the 5, so it goes from 0 to 4. But what is this going to do right here? I equals I plus 1. Will it go from 1 to 5? Will it count by 2s? And let's go ahead and run that to see what happens. When we run it, we can see down here that we get 0 through 4. This basically does nothing at all. And in fact, if I were to go ahead and change this a little bit, and instead of just adding 1, I add 10 and run it, I still get the same thing. Now, if I printed I after this, I'd get basically the values that I had before plus 10. But I don't go up by 10 every time. The for loop right here will take the I value, it'll reset it each time, starting at 0, 1, 2, 3, and 4. It doesn't matter what I do to the I inside of the loop, but at the end of the loop, it's going to be reset back to the value specified by the for loop. Block number 3. This, when I start the loop, X is set to 0. Then I run the for loop. And each time through the for loop, I'm adding 1 to X. I'm not printing it. This does not print 0, 1, 2, 3, or 1, 2, 3, 4, or anything like that because there's no print inside of this for loop. How many times does this loop operate? 5 times. I is going to equal 0 through 4, but I don't really do anything with I in the for loop. But I take X, which is an original value of 0, and I add 1 to it 5 times. What is 1 plus 1 plus 1? 1 plus 1 plus 1. Of course, it's equal to 5. X is equal to 5. Now, when I hit this print statement, I'm going to actually print out a 5, and that'll be my answer. Run it, and you can see down here, I've got my 5. Block number 4. Block number 4 is similar to what I had before, in that I've got this loop right here, I've got X set to 0, and this inside loop is going to run 5 times. And each time through, I'm going to add basically 5 to X. I'm going to add 1 to X 5 times for a total of 5 that'll be added to X. The difference from this compared to what my prior loop was is right here, I'm looping this entire thing 5 more times. If you've got something that adds X 5 times, and you do that 5 times, what you get is 5 times 5, or a total of 25. It's going to operate this 25 times, and X will then print out as 25. Clear this, run it, and indeed I can see down here X is 25. Block number 5. I'm going to print out what looks to be a block of asterisks, similar to what we've done before. I've got 2 loops, and I'm printing an asterisk in here. But what does this actually print when I run it? I actually just get a whole lot of asterisks. I get a total of 25 asterisks, if I were to actually go through the trouble of counting those. And the reason that I get them all up and down in a line is immediately after I print this asterisk right here, I'm printing with this a brand new line, and it carries on down here. I'm not getting a box because I'm not waiting until the row's done before I do the print. That's why I just get 25 of these asterisks going up and down. Block 6, almost identical to block 5. The difference being this has been moved in one tab stop. Now I go ahead and operate just these two lines, not the print the blank line, total of 5 times. When I run this, I actually get a box of asterisks down here because I went ahead and printed out 5 asterisks, and then from here I go ahead and print a blank line after I print this. Block 8. This is different from the prior one in that print is yet again untab stopped 1. What this means is this will run and this will run before I end up printing a blank line. I'll print these 5 asterisks, and then I'm going to repeat this another 5 times. All of that will happen before I print the blank line. So when I run it, rather than getting a box of asterisks, I get 25 asterisks in a row, and then finally this runs here, and I've got my blank line. Where you have the print indented matters quite a bit. When you've got loops, when you've got if statements, pay very careful attention to the indent to make sure that your statements run when you expect them to. Okay, block 9. What is a mistake here? Well, let's see what it outputs first. I've got an array, good. I set to 0. For I in array. Well, that's kind of odd. I set I to 0, but I didn't really need to set I to 0 because whatever's in array is going to be stored in I, obliterating the 0 that I had to begin with. What is going to first be stored into I? The first item in the array, which is 5. So I will be 5 after it's set to 0. Then I is equal to whatever I was before, okay, which is 5, plus array at location 5. Because I is 5 right now. 0, 1, 2, 3, 4. There's no 5th location. What I'm going to get is an error because it can't get to array location 5. Clearly, what the person thought when they were doing this is they were going to get 0, 1, 2, 3, 4, and also that they were using some sort of variable that hold a sum. In short, what you're going to get is an error. If you want to fix this, I need to do the following. This needs to be a separate variable. I'm going to call it sum. Also, I'm going to call this sum. And I'm going to call this sum. Next, I need to fix this loop. I can do it one of 2 ways. I can either do the easy way for item in array, and I'm going to go ahead and add item. I'm changing the variable name because I like to assume that when I use the variable I, it's going to be an increment variable, 0, 1, 2, 3, 4, 5. In this case, it's not an increment variable. I'm going to actually have the values 5, 8, 10, 4, and 5 placed inside of item. And then at the end, I want to print out the sum. If I run this, I get the sum of these numbers. The other way I could do it is the following. This uses the other type of for loop for I in range, length of the array, and I will then equal 0, 1, 2, 3, and I will add the sum position 0, which is 5, position 1, which is 8, position 2, which is 10, and so forth, giving me the same total of 32. Either way of correcting this for loop is fine. Certainly, what I did to begin with isn't going to work. Next up, block 10. What's going on with this? Okay, for I in range, 5. I is going to equal 0 to begin with. X is equal to 0. Great, X is equal to 0. For j in range, okay, j is going to equal 0. And how many times am I going to do this? I'm going to do this a total of how many? 5 times. X is going to go to 1, and then 2, and so forth, up to 5. When I'm done with this loop right here, where do I go? Up here, and I'm going to run the loop again. What happens here? X is set back to 0. I start it over again. It goes from 0 up to 5. I set it back to 0. It goes up to 5. It goes back to 0. And so forth until the last time through, when I do this 5 times, I drop out of here, come up here, I'm done with the loop, come down here, and I print out x, which is 5. I don't get a total of 25 because right here I am resetting it back to 0. Essentially every 5 times I go through with this loop, and I don't get a chance to get all the way up to 25 because of that x equals 0. Go ahead and run it, and indeed what I get back is 5. Next up, what am I doing? I'm importing random here. Play again is y, while play again is equal to y. Is play again equal to y? Well, yeah, I just said it that way. So I continue with the loop. For I in range 5. I'm going to do this total 5 times. And what am I doing? I'm printing a random.rand range. This gives me a random number from 0 to 1. So it would print out something like 0. I do not go to the next line because of this. And I loop. So like 0, 0, 1, total of 5 of these, because I got 5 right here. I print, so I go to the new line, and I print play again. If the user hits Y, then I'm going to do it again. If they hit anything else, including a capital Y or yes, then I'm going to drop out and write bye. Let's go ahead and run this. I can see I've got my numbers right here, and it's asking me to play again. Hit Y, I get new random numbers. Gee, that's a fun game. Hit N, prints by, I'm done with the game. Next up, block 12. Right here, I define a function, prints out x. Nothing happens yet. I've got to call this function before it does anything. Okay, y is equal to 5. Wait, excuse me. Y is equal to 3. I call f, and I pass it whatever's in y, which is 3. So this is going to be 3, right? Come up here. X is going to equal 3. I'm going to print x, so it's going to print out 3. And I'm done. That's what it prints. Go ahead and clear. Run. There's my 3. Next up, I'm starting to get into issues of scope here with this one and pass by copy as discussed in the chapter. I've got y equal to 3 to begin with, and I haven't printed anything yet. I'm going to make this my sheet of paper that prints out. F2, pass it y. Great. I come up here, and x is equal to 3 because I called it with whatever y was in y, which is 3. X is 3. I'm going to add 1 to it, which is 4, and I'm going to print it. 4. There we go. And when I'm done with this, I'm going to come back here, and I'm going to print whatever is in y. This original y didn't change, and it prints out 3. That's really all there is to it. Run it. There's my 4 and 3. All right, block number 14. Very, very similar to block number 13. The difference is the following. Instead of y, here I'm using x. But what I have are going to be 2 different x variables, even though they're both called x. To begin with, nothing happens here. This is what I'm going to print out. X is 3. I call f3. Great. I pass it whatever x is, which is 3. Come up here. Okay, wait. Here, x is 3. I come up here, and x is going to equal 3. But this is a different x variable. It is not the same x variable that I had before. Just like 2 people can be named Bob, 2 variables can have the same name. I add 1 to x. This x down here stays the same, and I'm going to print it out, the value of 4. Now I come down here, and I'm going to print this x right here, which is not inside the function, and I get a 3. Just like I did before. Run it. There's my 4 and 3. Block 15. Again, with this, I'm working with scope issues. What I've got happening to begin with, x is 3. Great, x is equal to 3. I call this, I pop up here. This guy's got a new variable called x is equal to 3. Called x. Set it equal to 3. I have two variables in play. Both are named x. Creating a brand new variable called z. I'm going to add 1 to whatever x was, so z is going to equal 4. I'm going to print z, which is 4. Great. I hop down here, and what am I going to do? I'm going to print z. But here's the kicker. Where did I create z? Inside the function. Any variable created inside that function stays inside the function. Outside of the function, you can't reference it. This is going to be an error. Run it. I can see right here, prints out the 4 like I said it would, and then I get this trace back, blah, blah, blah. Name z is not defined. It doesn't know what z is because it was defined inside the function. I try to use it outside the function. Doesn't exist there. Only exists inside the function. Block 16. Another problem dealing with scope. Criminy, you think I thought these were important problems or something. Okay, define the function. You can ignore that for now. X equal to 10. Print x is equal to whatever. Okay, x equal to 10. Call foo with x. Great. Flip up here. X up here. Brand new variable. X, set it to 10. Okay, this next line, x is equal to 11. I'm going to print out x equal to 11. Jump down here. What am I going to print out? X equals, and not this x, because that's inside the function, and it's gone now that the function is done. X is equal to whatever this is, so I print out x equal to 10. X equals 10, x equals 11, x equals 10. When I run it, I get x equals 10, x equals 11, x equals 10, just like I said. Block 17. This has less to do with scope, or not really anything to do with scope, and more to do with can you follow the function calls. Great. I start running up here, function definition. I can ignore it for now. Function definition. Can ignore it for now. Function definition. I can ignore it for now. Call f function. Great. I will drop up here, go up to f. And first thing in here I'm going to print out is f start. F start. I'm now here. I'm going to go to the g function. Print g start. Call the h function. Print h. Now that I'm done with the h function, I go back to where I was at before, and I'm going to print g end. Now that I'm done with the g function, I'm going to go back to where I was at before, which is up here. Call the h function. Oh, great. Go back down here to the h function, print out h. When I'm done with that, go back up here to where I was at before and print out f end. There you go. This is an example of nested calls where one function calls another function. And the key thing here is, can you follow this particular little bit of in and out in order to figure out what the computer is going to do? Hey, wow, block 18, back to function scope again. Nothing happens here. Set x to 10. Great, x is equal to 10. Print. Here's my print screen. X equal to 10. Call foo. Flip up here. X, oh, brand new x is equal to 3. I print foo has whatever. And then I'm done with this. I come back down here and I print this x is done, x equal to 10. X equals 10, foo has been called, x equals 10. Run it. There we go. Right down here. Okay, block number 19. Variable scope, but this time I introduce something new that's not in the text yet, and we don't really start talking about until we hit classes. First part, pretty darn straightforward. Function. Great, whatever. X equal to 1. I'm going to print main. whatever x is, which is 1. I call a, pass it x. Come up here. This x, which is different, is equal to 1. I print a, 1, add 1. Now I print out a, so x is 2, a2. Great. Hop down here, and remember this is a different x. This function's done. I'm done with it. I'm going to print out whatever this x is, and I'm going to print main 1. Okay, this is like the third time we've seen this. I think I've got that pretty well down. Let's take a look at the second part. Here's what happens. I've got a new variable, y is equal to 1, 2, 3, comma, 5. And to some degree, what I've written right here isn't exactly right. In fact, what really happens is the following. What I've got is y is equal to some sort of address. This is like a house address, except in the case of a computer, it's really dead simple. What I've got is a set of memory starting at 0 and going up to a really big number, depending upon the amount of memory you have. And there are little addresses here, let's say like 1010. This is actually where my numbers are stored. I'm going to store 123 here and 5 in the next one. Okay, so the address is 1010. And really what the computer is going to do is put y equals 1010, but it's nice and it hides it from you. And y essentially points to the 123 and 5. Therefore, when I do print main y1, remember this is spot 0 and this is spot 1, I'm going to go to address 1010, find the second item, because they're starting numbering at 0, and pull a 5, and what I actually end up printing out, over here, I'll just pretend it's my print, I'm going to print main 5. That's great. Now I'm going to flip up here with this call and pass the function b my address. Up here I create a brand new variable called y, same thing, and it's essentially going to equal 1010, the same address that's down here. Now I'm going to print out b. I'm going to go to this address, find the second spot, and print out 5. I'm now going to add 1 to it. I go to this address, the same address pointed to by this y, change this to 6. Here's the key thing. This is a copy of the address, not a copy of the list of numbers. Basically, it's like an apartment building or a phone number. You may have a copy of somebody else's phone number, but if you use that phone number, you'll call the same person that somebody else who has that same copy has. I'm now, whoops, didn't mean to do that. Still got B5 here. I'm now going to print B6. I'm going to return back here. Main is going to go to this address that I've got a copy of here, go to the second spot, and it's going to print main 6. In this case, what I've actually got is what's called pass by reference. And what I'm doing is using an address to go to the same spot. It is the address that's a copy. We also call it reference, just because address would be too simple. It uses that reference to that address and modifies the original list, allowing me to go ahead and modify that inside the function and still access the modified memory in part B. Don't understand it completely yet? That's okay. We'll cover it a lot more in classes, but I want to introduce the topic to you right now in this review. Next up, with this, okay, it's a function. Kind of ignore that for now. I've got y equals, all right, it's going to, I've got my memory right here, and I'm going to say y points to a memory address. Let's call it, I don't know, 1100 will be my memory address. This is my 1100. At this location, I store a 123. I also store a 5, just like I did before. Great. I'm going to print main and then whatever is at spot 1. Remember, this is spot 0, this is spot 1, so I'm going to print out main 5. I now call C of Y. Hop up here. I'm going to print C, and Y here is going to also equal 1100. It's a copy of it. Point to the same location, and I print C, Y with 5. I now set Y equal to a new spot. This doesn't destroy this. It actually creates a new Y. Let's call it 1000. It'll no longer point here. It'll point here, and I've got 101 and 102. Because this is a copy, I did not change this original Y. And I've now got C, and I print out 102. I drop back down here. I've still got the original 1100 address, and I print out a main of 5. Since the address is a copy, if I create a brand new list, I've got a brand new list, and I can modify it all I want. The original list isn't modified. Again, it's a bit to understanding that arrays and lists are pointed to by addresses, and when you call a function, if you realize that, you can predict fairly well what's going to occur.